Hello guys, in this video we will see how to perform or carry out item analysis when you have dichotomous data. That is, with help of item discrimination we can carry out item analysis. When you have Likert data on the other hand with a slight variation in the formula, you still can go for item analysis with help of item discrimination method. Whereas on the other hand, third method is also equally popular, that is, with corrected item total correlation you can compute or carry out item analysis. So there will be three different calculations over here. In the very first we will see that with help of dichotomous data, how to compute or how to carry out this item analysis with help of item discrimination method. Now there is this popular suggestion by Kelly in 1939, says that best strategy is to select upper 27% and the lower 27% of the respondents, and then within these two extreme groups of scorers we will see how much the item is discriminating or not. And for that you need to have total for the items, like total score for the items. Now in this fictitious data you can see that I have 10 items and there are 20 respondents in my like in my for my data, for my scale. So here you can see in the first column I have name of the respondent, followed by age, gender, ID, and actual responses for items start from this till this last cell, the range. Now first respondent in my fictitious data is Abhishek. Now I'm interested in finding out total scores for all the respondents in order to arrange them in descending order. That is required to find out first 27 highest scorers or and lowest 27% of scorers. So for that I need total. So for this I'll use formula of equal to the summation, and double click on that and select these values. It'll give me total for my first respondent, and if I drag this down I'll get it for all the respondents. Now I need to arrange this entire data in descending order with respect to total scores of the respondent. So in order to do that I'll have to select the entire data. Once I select that, I'll go in home. On this top ribbon you can see that I have home as an option, and in this I have this sort and filter option over here. Once I click on that I'll go for custom sort, and in this there is a small box, my data has headers option, so make sure that you click on that or check on that. So it will give you sort by options over here, and now you can see that I can sort by all these headers. So I need to sort my data with help of total scores or with respect to total scores. So and then that will be from largest value to the smallest value in descending order. I'll click on OK. This will sort my data. Now you can see that my first respondent is no longer first respondent but is 10th respondent, and the highest scorer is second and sixth respondent respectively. Like both are scoring actually the same value, 9. Whereas lowest scorers, you can see 3 is the lowest score on my scale. Now I'm interested in finding out the number of respondents that will be there in the first 27% of respondents. Now in my data, as you can see that I have total sample size of 20. So 27% of 20 are 5.4. Now I can either go for 5 or 6. I can't have a decimal in my total, like in number of cases. Cases will be a whole number. So in this particular case I can either go for 5 or 6. If I go for 5, that will be 25% of my total sample. So first 25% and the last 25% I can see. Or if I go for 6, there'll be that will be 30% of my data. So first 30% respondents and last 30% respondents I can compare with. So now this is a close call, and it is all up to you to select that number. So particularly I'll go for 30 for my convenience. So I'll write upper 30, that is first 30 respondents. Then I need lower 30, that is least 30% of scorers. And then I'll be interested in computing DI, that is nothing but this discrimination index, that is item discrimination basically. So item discrimination, each item will have its own unique value of discrimination, may not be unique at times for both, for a couple of items it can even be same. So, and for all the respondents if you have, that will be called as index. So discrimination index I will call it as. Now I'm interested in first 30 cases, first 30% of cases, that is first 6 respondents. How many are getting this particular item, that is item 1, as correct. So for that, all I have to do is I'll put equal to, I'll have to use formula summation. I'll double click on that, and then I'll have to select first 6 responses for responses given by 6 first top scorers. So I can select over here 3, 4, 5 and 6. Okay, so these are 6 respondents. Now I'll complete this bracket. I need one more bracket above it, so because since it is going to be one like complete formula, so I'll insert one more bracket outside of it, and now I'll have to divide this value by 6. I need mean of the correct responses over here. So 6 respondents are there, and this is the total will be divided, the total correct responses will be divided by total number of respondents, that is 6. So that will give me upper 30% count. Where you can see that it is 0.83, that is 83% of people scored it correct, remaining scored it wrong. Now in lower 30%, I need to check how many respondents, or how many percent of what percent of respondent have solved it correctly, in correct manner. So I'll go again for equal to sum, double click on that, and now I'll have to select last 6 respondents. So carefully I have to select last 6. So these are my last 6 responses. If you see, I'll complete this bracket, put one more bracket outside of this box, outside of this formula, and then I'll have to divide this also by 6, that is total number of respondents, that is 6 in my last 30% of respondents. So this will give me L30, that is lowest 30, we can say lower group and upper group. And now discrimination index is nothing but difference between U30, that is upper group, and lower group. So I'll simply put formula as equal to this value, that is U30, minus lower group, that is L30. I'll click on enter, and see, this is discrimination index, discrimination value for this particular first item. Now if I select all these 3 and drag this for all the items, I'll get item discrimination index for all the items over here. And now if I want discrimination index in percentage, now it can ideally, it should range from it ranges from -1 to +1, but in some books you can see that discrimination index is actually given in percentage. So you can for your ease, you can actually multiply these values of the discrimination index by 100 in order to get percentage. That you can even here you can do that. I'll call it as DI percent, and that will be nothing but this value will be multiplied by 100, and now it is in percentage. And if I drag this, I'll get percentage for all the items. So you can have it in percentage, or you can have it in decimals. So in decimals it will range from -1 to +1. In case of percentage, it will range from -100 to +100%. Okay, so now this is how much this item is discriminating between the respondents. Now rule of thumb over here is 0.0 to 0.2 are actually not discriminating much. So those items can be actually removed from your data, from a scale, whereas items having discrimination index of 0.2 to 0.4 are starting to become discriminating, whereas items which has value of item discrimination more than 0.4 are strongly discriminating between the respondents. So in this case you can see that as per this cutoff strategy, if you go for like above 0.2, I will select items till 1. So below 0.2 I can point out that this item 3 is having a low value. On the other hand, item 5 is also producing some sort of negative value over here. And one more, item 9 is also producing very low value of 0. So these three items are actually not you know are not discriminating much between the highest and lowest scorers of this point of the data. So you can actually remove these items. So item 3, item 5, and item 9 are actually not producing satisfactory discrimination between these respondents. Okay, so this is easy in case of dichotomous item. What if you have Likert scale? So in this second part we will see now how to perform discrimination, item discrimination in case of Likert scale. Now in Likert scale there are no as such right or wrong responses. Now this is another fictitious data I have, wherein I have Likert scale I've used. So the least possible score on an item is 1 and maximum possible score on each item is 5. So it is basically a 5-point Likert scale ranging from 1 to 5 as the responses. So there are no right or wrong responses as such. But now this is a Likert data, and again I'll have to follow same sort of similar steps. Over here I'll have to write total. We will be using Kelly's suggestion only, that is 27%, top 27 and bottom 27% of cases. For that I need total scores. So for total I can simply use this summation formula, and I'll select all these items till 10th. This gives me value for the first respondent, drag down for all the respondents. So this is total value I have. Now I need to sort this data in descending order, that is from highest score to lowest score. In order to do that I'll have to select entire data, go in home, sort and filter, and custom sort my data. Now again this box I have already checked, so I'll have to sort my data with help of total scores, and I need to have it from largest to smallest. So I'll click on that. This will sort my data, and now you can see that fifth respondent ID 50 is actually scoring the highest, and ID 17 is scoring the lowest value, which is 41 and 14 respectively. Now in this particular data, again see, basically we are going to use similar sort of formula, but then a slight difference is there in the last step of it. So we will again go for u. Now in this case particularly we will be computing mean for the upper group, mean for the lower group, and then we will be subtracting upper mean from lower mean, lower mean from upper mean, and we'll be dividing that subtraction or result by maximum possible score on one item. So we will step by step do that. In this first we will call it as u mean, that is upper group mean. Then L mean will be lower group mean, and then I'll be interested in discrimination index, which shall range from -1 to +1 in the same manner that it has ranged for the dichotomous items. Now in this particular data, again fictitious data, I have 20 respondents only, so I can either stick to 5 or 6 as described earlier. That consists of 30%, so I'll stick to 6 respondents. So in this particular case 6 respondents will be there, so I need to calculate mean of the top scorers. So mean will be calculated with help of sum, and we'll divide that by total number of people, that will give me mean. So basically I'll put equal to, I'll put sum, so I'll summation of first 6 responses, so 3, 4, 5, 6. Okay, so you can see that I have selected first 6 responses. I'll complete this bracket, put one more bracket outside of this formula, and then divide this value by 6, since total number of responses I have 6 over here. So 6 people are responding to one particular like first item in my data for my scale. Okay, so this is mean of first upper scorers. Now mean of low scorers or lower group I need. For that same formula, sum. Now carefully select last 6 values, complete this bracket, put one more bracket outside of it, divide this value by 6, because 6 respondents are there for the lower group. This is giving me lower group mean. Now in this last step, now since like we have followed almost similar steps so far, but in DI, discrimination index, we simply need not to subtract values, but we'll have to divide by maximum possible score too. Now in this particular case, that will be um, equal to this value, that is upper mean subtracted, lower mean will be subtracted from upper mean basically. Put brackets and divide this value by 5. Now this 5 is not number of cases, but 5 is maximum possible score on one item. It's essential to divide it by. Now this gives me discrimination value for this particular item. Now I need to simply drag these three values for all the remaining items. It will give me discrimination index. Now see, again here you can see discrimination index, whereas in this particular example, now item 5 is pretty much on the borderline, that is for my cutoff criteria is zero point 0.2 and above, so it's still meeting the criteria. In other cases it's pretty okay. So yeah, still like item 5 is uh, you can remove item 5 if you want to. Apart from item 5, other items are actually pretty much doing well in discriminating between the high scorers and low scorers. Now since this is essential to know that it's not just discrimination index you decide whether to keep item or to discard it from your test, but equally important is to see theoretical importance of that item. So I'll suggest you to go for content analysis, or else at least check theoretical importance of that item before deleting. If it is theoretically important, though it might not be producing a very high discrimination value, you can still reword that item and use it. So it's not just about discrimination index but also theoretical importance of that item. Alright, so this is for the Likert data. A very slight difference is there in the formula if you see for Likert data and for this dichotomous data. Now third very popular method is corrected item total correlation. In this particular method, what we do is basically it's very going very close again to the internal consistency reliability. So instead of internal consistency, we'll be actually purifying our test. In that also we can, with help of certain formula, we'll come to that, we actually purify our test. So with help of corrected item total correlation value, we can remove certain items which are not actually homogeneous in our test and which are not actually measuring what we intend those items to measure. So those can be removed from the scale in order to produce a good scale. So for that particular method, that is corrected item total correlation, we need SPSS. So in SPSS, I'll simply put this Likert data. Now for this Likert data, we can compute it in SPSS. I'll simply copy paste this data. I've copy pasted over here already. So in variable view, you can check that how I have defined these variables. In name, you can't have two different words, so I have coined those as like I1 stands for item 1. In label, however, you can use your creativity and you can have even space between two values. So item 1 I can completely write over here in label, but in name I can't do that. So, and apart from that, these other values are by default selected by SPSS, and these values I have selected by like manually. Scale, so you need when you have Likert data, many authors are of this view that, or many researchers are of this view that if you have Likert data, it should be considered as scale measure. However, there are some differences, and some people even go for ordinal data, so we'll stick to scale. Alright, so in data view, you can see that I have 10 10 items and 20 respondents in my sample. This is again a fictitious data, same data I have copy pasted over here. So in analyze, you can go in order to compute this corrected item total correlation. Go in scale, reliability analysis. Now in this type of dialog box will appear over here. There are total 10 items. So I can select all those in one go with help of Control A and click on the small icon, will shift my items in the second box called as items, named as items. Okay, so I can see that all my items are I've transferred those in items. In statistics, I need to check certain values. In descriptives, for I'm interested in all three, so item, scale, and scale if item deleted. This last function, scale if item deleted, is pretty interesting, we'll see that. And then I'm interested in inter item correlations, so I'll click on that. Apart from these three values, I'm not interested in any other value, so I click on OK. In model, I'll suggest you to go for alpha only, since it gives you internal consistency apart from the total item total correlation and corrected item total correlations. So click on OK. This will generate your result. So in output, you can see that these values over here. Then cases, you can see that total number of cases are 20. So all cases are valid in my data. Here you can see that Cronbach alpha is 0.794. For Cronbach alpha, again, there are different cutoffs given by different authors and researchers, but then very popular one is that it should be above 0.7. Any value below 0.7 is questionable, above 0.7 is acceptable, above 0.8 is good. Now our value is very close to 0.8, but still it is not exceeding 0.8. We'll see that what to do about it later. And in item statistics, you can check mean and standard deviations for each item, and n is 20, that is 20 respondents. Inter item correlation matrix is pretty actually the values we are interested in. So in item 4, if you see, item 4 is negatively correlating with item 1, which should not be the should not be the case, since this data is of one theoretical construct only. So it is measuring the similar theoretical construct, or the only one theoretical construct. So it should not have negative correlation with other items, but still it is having. So this item actually is may not be performing good, which we would be interested in to check that. Even item 5 is producing negative correlations, and there are a couple of other negative correlations over here. If you have inter item correlation matrix with most of the values above 0.3, then you're pretty close to a very good internal consistency reliability. However, in this data, you can see that there are a couple of values which are actually negative, and pretty high values are there in the data. Like for instance, this particular value, if you see, it's minus 0.267, pretty high negative value. Alright, so in this next table, you can see item total statistics, and in this third column, if you see, corrected item total correlations are available for us to check. Now this is the value I was talking about for item analysis. So in this case, you can see there are 10 items, and there are values corrected item total correlation. First, let us understand what corrected item total correlation mean. So it's nothing but correlation of, like for instance, let's say this first item. So first item, that is this value 0.140 is nothing but correlation between remaining 9 items, total of remaining 9 items, that is consist of one column, and then the second column for correlation will be responses on item 1. So responses on a particular item and responses on other remaining items collectively, like these two values will be correlated, and correlation coefficient between these two columns will be nothing but corrected item total correlation. Now corrected because this value of one item, or values or scores of one item, are removed from the data, and that are being correlated with the remaining number of items. In this case, there will be 9 remaining items, so that is correlation between these two values. Now if you see, again, there are certain cutoffs over here. So as per, like, many researchers are of this view that it should range between 0.3 to 0.7 ballpark. So it should be above 0.3 and it should not be above 0.7. So in this particular case, if you see, item 1 is low, and whereas item 5 is also producing very low total item total correlation, corrected item total correlation. Apart from that, other items are doing pretty well. These particular item 2 and 3 are actually scoring above or having values above 0.7. Now we can actually start deleting these items. but I would suggest you to not to delete multiple values at a time, because once you delete one particular item, it is bound to change other values too. So you won't be able to see how other values are actually changing. Now for instance, this value is pretty close for item third. Value of 0.725 is pretty close to 7. It can even get reduced if you delete one of the items, so need not to delete directly item 3 as well from the data. So step by step, one or two items I would suggest to delete. Now in this particular case, I'll be deleting one by one, and so let us start doing that. So first item I will delete, as it is producing the one of the lowest values, or else you can go for, actually I can delete this fifth item because it is producing the lowest value for my in my data. And you can see that once I delete this particular item, my cronback alpha will be improved and will shoot up to like 0.823, which is again good cronback alpha, or that is internal consistency, that is above above zero point 0.8. So I'll delete first item 5 from my data, and let us see other remaining values too. So go in, analyze, again scale, reliability analysis. I'll simply put this item out of this box. So item 5 has been removed. You can see this item 5 producing low value, and click on OK. This will generate output. Now you see that cronback alpha is 0.823, which is high, which is good value. Now you see this these values. Now again, item 3, if you see, it is slightly reduced now, still will not touch that item, whereas item 1 now is the case to remove, since it is also producing very low value. So again, go in, analyze, and we will this time remove item 1 from our data. Scale, reliability analysis, I'll remove item 1, click on OK. Now if you see that cronback alpha is pretty high, 0.854, and item total correlations, now you can see that the item 3 is now producing lower value than 0.7. So this is the advantage of reducing one by one the items one by one. So now if you see, all values are almost acceptable, only item 2 is exceeding 0.7. So in this range of 0.3 to 0.7, only item 2 is exceeding that, so we'll have to remove that item as well. Go in, analyze, scale, reliability analysis, and item 2 this time I'll be removing. And now you can see that my cronback alpha has dropped a little, it is 0.818 now. But if you see the corrected item total correlations, they are all now in the range of 0.3 to 0.7, which is acceptable range to have in a good scale. And cronback alpha, if deleted, are pretty okay. Like my value is anyway above 0.8, so I'm not worried about internal consistency as such, and it's producing a very good internal consistency with 7 items. So I've removed 3 items from my data. I'll stick to these remaining 7 items. Now one more caution over here is to understand that it's not just about deleting item based on the corrected item total correlation value, just like in case of item discrimination I've told you. So don't directly delete that item, see theoretical importance of that item, and if it is theoretically important, I would rather suggest you to go for content analysis and reword that item in appropriate way, and maybe after that that item can really perform good. And some other suggestions are also there apart from content analysis. Now like one more thing I need to explain over here is why we are deleting. Now many people would be interested to know that why I'm deleting values which has above the corrected item total correlation above 0.7, since it is actually helping us to boost our internal consistency. But corrected item total correlation is correlation coefficient between your item of interest and the remaining items in your test. If this correlation coefficient is above zero point 0.7, it means that more than 50% of variance is common between the item of interest and remaining items in your test. In other words, this item is not producing significant amount of variance and is measuring more or less the same thing what the remaining items are collectively measuring. Thus, corrected item total correlation above zero point 0.7 indicates some redundance in contents or wording. In that case, I would recommend you to do content analysis to decide item selection. I would encourage you to use both statistics and theory in your item or scale analysis. So, in this video, I have shown you how to carry out item analysis with help of item discrimination method, which we have seen for both dichotomous and Likert type data. And the second method I have shown to you is item analysis with the help of corrected item total correlation. Allen and Yen in 1979 argued that both practices cannot be used simultaneously, that a test constructor must choose one or the other. Anastasi, on the other hand, in 1988 argued that both are important. Now I leave it up to you to perform item analysis with both the methods or to choose any one of these two. If your test is generating dichotomous data and you are interested in carrying out item analysis with help of corrected item total correlation, SPSS does not provide you with KR20 as an option. So I would suggest you to do item analysis with alpha only, that is scale you'll have to choose alpha only. So you'll have to follow the same procedure which I have shown to you in SPSS for dichotomous data too. If you have SPSS, fine, you can do that. But if you don't have SPSS, you can still perform item analysis with help of item discrimination method by using Microsoft Excel. Thank you for watching this video tutorial. If you face any difficulty in carrying out item analysis, feel free to contact me and I would be happy to assist you.